We are friends from a same town in Slovakia. And yeah, you can go on the next slide. Alright, so we tried to put focus on search query as we went through the Newsmatics search query and it was case sensitive and we thought that we could add like sentence transformers and make it more sophisticated. I'll guide through this workflow with my colleague Peter here, and as mentioned here, we use function article grabber to get an API from Newsmatics to create a database file where we exported all the data that we needed for this project.
Yeah, so as Lukáš said, in our database renamed Biota, we have all our important data we need, more specifically the data of the articles we obtained through the Newsmatics API. And after obtaining all this data, of course, there was a lot of it, so for the sake of this hackathon, we didn't extract all the data database naturally, so we only got a sample portion of it. And we pretty much ran all those article data through our embedding model to create the vectors for it, which could be later stored in separately in our database, and then we can work with them in order to achieve optimize simulated search based on the user search query. And well, how the user can access what he wants. So we've got our Deadlock API, which the user can access through our Deadlock website, which is currently running on a server. We'll get linked to that. And basically, through this website, the user enters a search query for a piece of, let's say, an interest they are looking for some specific articles regarding this area of interest. Then the search query goes through a transformator in order to optimize the query and work better with our API and our database. Then it goes again through the embedding model and tries to find the best suited articles from the News Index API. From the Newsmatics article database, but they are stored locally or could be also stored locally or also remotely on our Biota database. And then at the end, the articles returned via our Deadlock API are then returned to the users on the website, and it should work more. It should have increased optimization in comparison to the Newsmatics API, and it also clusters all these articles inside or beside them and creates this cluster of articles which are near each other, and then they are grouped together.
Thank you.
So I will just run through some future scopes. We hope our project will turn out successful and found its implementation in your company. Also, we want to add better indexing, more reliable system for vector similarity search and embeddings. And also there is a need to upgrade our so-called trust factor to make it more reliable and relevant for users to handle this information. And that's it from the presentation, and we want to show you some use cases. So this is basically our website that we built. Well, as you can see, it's quite similar to the one that Newsmatics used. That was actually our idea because we wanted to show you how embedding technologies could be used and implemented on a website which has a similar design. As you can see, there are some filters on the left. There's nothing new, and we added categories under the search bar, which, when are selected, will tell the prompt how to better navigate through the vectors and find better results. You can also only select them and search articles without putting any search query, which will give you the newest articles from the area of your of the category you have chosen. Yeah, I play games a lot, and one of my favorite games is Forza Horizon. And as you can see, you can just search it up, and it will give you many results which are connected to the game. Yeah, this is basically the category system I told you about. And yeah, we have implemented this button here, which is basically like a generative prompt, which will generate a random prompt, so you can search up a random sentence that will give you some results after it loads. And we have embedded approximately 100,000 articles for this, and you can play this demo live on your computer because we have done it like that. Yeah, if you want to do it, if you want to search something up, you can do it now. Thank you.
A second. It takes 5 seconds before it warms up.
Thank you very much for the presentation. Can you tell us what embedded model you use?
All of this, it was new to us, so we really did go into this with no past experience, and we used OpenAI's text embedding ADA 002 to embed all those articles, and also for the sequence transformers for the user's query.
I see. And can you tell me more about what the sentence transformer do?
Basically they also have a system query to further enhance the user's query, and all we basically do is tell the model to take the query that the user has prompted and further improve it, add a little bit of more information so that the final embedding of the query, user's query, is more accurate to the actual results he wants to find. So I don't think that answers the question.
Yeah, I was about to ask about similar things, like if you check how it looks well, and then make sure which query is converted into what is then turned into the embeddings, it looks like reasonable compared to the text you then feed to the embeddings. The embeddings are contributed for the articles, and they tell you this is about something, but the user usually asks about in generic terms, which you ask about, for example, Japanese food, but it's a generic term, and you need to create specific embeddings for individual Japanese food, I guess. So if you have seen how it transfers the sentence into what is then fed to the vector comparison.
I don't think I quite understood you, but I can try to answer your question. Basically what we do is take the user's query, let's say the Japanese food, and we prompt it to the sequence transformer using the OpenAI's ADA. And I don't actually remember what the system prompt is to further enhance the user's query, but we add just few words to further enhance the user's question sentence, because sometimes users don't actually put in the whole sentences. They usually put one word and expect to find what they are looking for. So we try to predict what they are more accurately looking for by the sequence test.
Yeah, that was actually kind of my question, because sometimes you type exactly what they are looking for, but sometimes use natural language to describe a whole set of things you are looking for.
We looked into the actual output of the sequence transformer, and most of the times it was when we put in a more precise question, it didn't really change it. But if it was something generic, it really did further enhance it to improve the output.
Okay.
Yeah, I mostly had a question about the query pre-processing, because it seems here kind of important. Also, I would like to know how deep you went into researching about how they can actually work. I'm not really sure why I use the old models though. Why use GPT 3.5 to do the query pre-processing? We could just use the new models which work way better for this.
Yeah, we had a problem with efficiency. It took quite a lot of time to actually process and get the answer. So we experimented with other models too, and we chose the time efficient one, not the I don't know how to say it, but the better results. It didn't really change the output. It was still quite alright, and it saved a lot of time, several seconds.
And if you did go further into the query, because it doesn't really since you use the semantic search, correcting spelling mistakes doesn't make much sense, since it's should capture the semantic stuff anyways. But if you go further into the research about what to do with the query itself, what would you explore? What methods would you use to go further?
Well, that was the problem with this project at the time, because we would love to explore more, even with the embeddings. We were experimenting with it and tried it a few times, and once it looked quite alright, and sometimes we got the results we were looking for, we went with it, and the question you are asking, we unfortunately didn't have a lot of time to look into it. Like I told you, all of this was new to us. So.
Okay. Anyways, the interface looks really good for the presentation. It's nice that you the same approach, so it looks very good for the company. Thanks. Thank you.
Thank you guys.